You're doing it!
Look who's finally ready to play.
Let's see if I remember how to do this.
Oh man, that's his airness, Michael Jordan. He said he's ready to play. He just had to figure out if he remember how to do it. Of course he does, and also R. Kelly there. Everybody loves it, you know. Here we go, getting started on section 4.1 of Unit 4. Talking today about ratios and proportions. So let's jump right into it. All right, so first of all, what is a ratio? Basically, a ratio is a comparison of two things using division. Okay, so we're going to look at division. It has to deal a little bit with fractions, so don't freak out. But really what we're going to do is we're going to compare two quantities, sometimes of the same thing, sometimes of different things. All right, so when I write a proportion, really I'm going to look at writing it three different ways. But again, what we're going to do is we're going to compare two quantities, say A and B. First way I can write is just simply write it down as a comparison of A to B, whatever those two numbers may be. Second way is to write it with a colon. A, and now this is going to also represent the way you would say this is A to B. And the last way, the one we're going to do it most commonly, is written in fractional form as a division, is comparing A to B. Okay? Each time you look at these, no matter how it's written, you always read it as the ratio of A to B. It's a comparison of two things. And understand that a ratio simply means that you are comparing those two things, whatever they may be. All right, so let's do just a quick example of writing down a ratio. All right, so it says Mr. Wazakowski has 15 Autobots and 12 Decepticons in his Transformer collection. Nice little Transformer collection of action figures, not dolls. So the first one says find the ratio of Autobots to Decepticons. Okay, so when I write this ratio, again, a ratio is a comparison of two things. Now notice how it says Autobots to Decepticons. So think of this as A to B. So I'm going to write this in all three ways. What I can say is the number of Autobots I have was 15, and I can compare that to the number of Decepticons, which is 12. So one way I can write it is 15 to 12 as a ratio. The other second way I can write it is using the colon. So 15 colon 12. That again is going to read the ratio of 15 to 12. And the last way I'm going to write it, which I want you to get more used to, is writing it as a fraction. 15 over 12, which again, this means the ratio of 15 to 12. But the last thing, and I kind of didn't mention on the last slide, is that when I look at this in fractional form, what I want to make sure to do is simplify it. Okay, so if I simplify this, what number goes into both the top and bottom? Both of these you can put in 3. So this would be 5. Sorry, this would simplify the top to a 5. Bottom would simplify to a 4. So therefore, this ratio becomes 5 to 4. That means overall, there's a 5 to 4 ratio of the number of Autobots to Decepticons that I have. That means if I have 5 Autobots, that would represent that I also have 4 Decepticons. So in the simplest form, this ratio is a 5 to 4 ratio. Okay. Now let's flip it. Let's find the ratio of Decepticons to total Transformers. Ooh, total Transformers. Okay. So how many Decepticons do I have? Well, I know that I have 12 Decepticons. To how many total Transformers? Well, total Transformers, what I'm really looking at is my Autobots plus the number of Decepticons I have. So that's my total amount. So that is 15 plus 12. That's going to give me 27. Okay, so this is going to be a ratio of 12 to 27. Now, the last thing I'm going to look at is, can I simplify this anymore? Well, sure. Okay, what number goes into both 12 and 27? Well, we can think through it. We maybe can think of 3. 3 goes into 12 4 times. 3 goes into 27 9 times. So this is going to simplify out to 4 over 9. Okay, so that means the ratio of Decepticons to the total number of Transformers is 4 to 9. So that means if I were to have 9 Transformer action figures, I would have 4 Decepticons, and 5 of those 9 would have to be Autobots. Well, then that kind of goes back to what we said in the first example. So notice how we can use these ratios to represent or compare two different things. What you're going to have to make the connection with this chapter where it's difficult is connecting the actual value of the fraction to something we see in real life. Okay, another example. Mr. Wizakowski has been learning how to tie his brand new J-Bones. That's why I kind of showed you the Space Jam video, my favorite shoes of all times, and you know how Cudahy folk love shoes, is what Mr. Jordan is wearing down here. I believe it's the Retro 11s. I always get it mistaken with the Retro 9s or 11s. I think it's the 11s with the blue gummy bottoms. They are so fresh. Look at the picture up here. Okay, those are sweet. I used to have them as a kid, but now they're like 150 bones, and I'm not going to buy those. You know, that's too much. Okay, but let's say I'm learning how to tie my brand new Jordans. I forgot how to tie my shoes, but now I'm learning how to tie it again. Yesterday I attempted to tie these new kicks 18 times, but I was only successful 6 times. So the question's asking, find the ratio of the number of times he was not successful to the total number of attempts. So in the problem, what am I giving you? Well, I told you that I attempted this 18 times. Okay, so as a fraction, I'm looking at the number of times not successful to the total number. Okay, so 18 times my total number. If you think of your fraction, okay, remember when I say A to B, B is going to go down low, A is going to be down top, or it's down top, on top. Okay, so that means as this ratio, 18 times, the total number is going to be on top. Now, the number of not successful, unsuccessful attempts. It says that I successfully attempted it 6 times. So if I did it successfully 6 times, of the 18 times, how many did I do unsuccessfully? This should be 12. How did I get that? I just subtracted. So that means the ratio of unsuccessful attempts to the total number of attempts is 12 to 18. So the last thing I can do is try and simplify. Is there a number that goes into 12 and 18? Well, yes, 6 does. 6 goes into 12 2 times and into 18 3 times. So what does this become? This becomes 2/3. Or the way I want you to write that, or not write it, but really to understand it, is 2 to 3. The ratio here is a 2 to 3 ratio. That means for every 3 attempts, I was unsuccessful 2 times. I completely forgot how to tie my shoes. I think I should go to Kmart and get myself some little Easy Striders. Those are the ones with the Velcro straps. That's what a real dude would do. All right, next one we're going to look at what's called a proportion. And you may not have realized it, but a proportion is stuff that I've already been doing already. Okay? A proportion is basically saying that 2 ratios are equal. So you can see the form here, the general form, that A to B is equivalent to C to D. The way I like to represent this, or really think about it, is as a fraction. If I say a fraction of 1/2, okay, here's the way I like to represent a proportion. There are multiple ways in which I can represent 1/2. For example, if I have, instead of a denominator of 2, if I think of a denominator of 8, how many would be half of 8? Well, 4 would be half of 8. Right here, what I have is a proportion. The same thing could be said about 1/6. Okay? If I say instead of 6 and I change this to 18, how many 18ths would be equivalent to 1/6? Well, I can think here, how do I get from 6 to 18? That'd be times 3. I could do the same thing up top, times 3. That would give me 3 over 18. What it's saying is that 1/6 and 3 over 18 are equivalent fractions. Okay, meaning the ratios are exactly the same. So a proportion is just looking at 2 ratios that are exactly the same. But what I can do is I can use this then to solve problems. If let's say I have, a ratio of 1 to 2, so say for example I have a ratio of 1 to 2, and I'm trying to figure out how many of 50 do I have then. If the ratio of something is 1 to 2, if I had 50 of total amount, how many would I have? If I'm comparing 2 different things, 1 to 2, and now I'll change it to 50, I can use a proportion to figure out how to solve this. Okay? And if you look at this, yeah, you see fractions, but what we're doing here is we're dealing with a lot of things we did last chapter in solving equations, especially solving equations with fractions. Okay, so let's go through some examples of solving proportions. The way I want you to solve this is to solve this how you would an ordinary equation. So first of all, I have over here 22/6. Okay, 22 to 6 is my ratio. I want to know how many out of 15 would be the same as this ratio. So the way I got to look at this is, okay, I'm going to look over here just thinking about solving equations. I have x over 15. What does that mean mathematically? Well, that means that I'm taking x divided by 15. So in order to get rid of that 15, I'm going to multiply. Woo! Little sneeze there. Absolutely, that's fantastic. That means if I multiply that side by 15, I have to multiply the other side by 15. Okay? Now, on this side, I'm taking and multiplying 15 over 1 times 22 over 6. Think about what do you do when you solve fractions like this. I'm going to try and simplify first. So notice here, a lot of people forget to do this, but 15 and 6 can be simplified. The number of 3 goes into 6 2 times, and in the 15 5 times. So now I can simplify this to 5 times 22 over 1 times 2. So this is going to tell me that x is going to be equal to 110 over 2. Now the last thing I'm going to look at is with any sort of ratio. So basically what this is simplified out to is that x would be 110 over 2. Well, if you think about plugging that into fraction, that's not good, but I can simplify this. So notice how 110 is even, 2 is even, so 2 goes into itself 1 time, and into 110 55 times. Okay, so that means x is going to equal 55. So here's basically what I'm saying, is that 22 over 6 as a ratio is the same as 55 to 15. To show this to you, let's simplify both sides. Okay, watch. 22 and 6, what number goes into both of them? Well, 2 does. 2 goes into 6 3 times. 2 goes into 22 11 times. So this simplifies out to 11 thirds. Okay? 55 and 15, what number goes into both? Well, 5. 5 goes into 15 3 times, and 5 goes into 55 11 times. And that simplifies out to 11 thirds. So notice how I have two different fractions, but when simplified, they both represent 11 thirds. And that's exactly what a proportion is. Because all I'm doing is writing a fraction in different ways so that I can describe, I guess, or compare two different things. Okay, next example. I'm going to go through a little quicker now. Okay, so 9 over 2. 9 to 2 is equal to m to 12. So what is m going to be equal? So I'm going to do the same thing here. To solve for m, I'm going to multiply by 12 first to get rid of it because it's being divided. Therefore, I'm going to multiply this side by 12. Okay, I'm going to change this to 12 over 1 since we're multiplying fractions. Simplify the denominator of 1. Goes into 12 6 times, for 2. What I'm left with is 6 times 9 equals over 1 times 1. So 6 times 9 is going to be equal to 54, and that's going to equal m. So m is going to equal 54. So again, what this is saying is 9 over 2 is equivalent to 54 over 12. Again, I could simplify that, but I won't do that there. You can show it if you want. Okay, next one. I have 5 over 13 equals k minus 4 over 39. Okay, so now I got k minus 4. We did problems like these before. Remember, this is solving equations. You think about adding 4 first, but remember, just like the last couple problems, both k and 4 are being divided by 39. So I'm going to multiply by 39 first to get rid of it. I'm going to multiply this side by 39. I'm going to again put it over 39 over 1. It's going to cancel out on that side. Notice how we're kind of repeating how we solve these problems over and over, which is perfectly fine. Well, can I simplify it? These are big numbers. So 13, yeah, this goes into itself once, and believe it or not, 13 goes into 39 3 times. So what I'm left with is 5 times 3 over 1 times 1. That's going to give me 15 equals, not k this time, but k minus 4. So the last thing, if I add 4, ba-boom, add 4, ba-boom, I get 19 equals k. Again, if I want to check it, I could plug it back in. Two more examples here. Next one, I got 3r over 5 equals 36 over 15. So now I got 3r here. That's perfectly fine. So I'm going to do it the same way. Watch this. What am I doing first? I'm dividing the top by 5. So let's follow the same process. So instead of doing anything with a fraction, I'm going to multiply by 5 first. That's going to cancel out that 5.
but then I have to multiply this side by 5 over 1. Go ahead and simplify. 5 goes to itself once, into 15 3 times. And what am I left with? 3r equals 36 over 3. Okay, before I do anything with the left side, let's go ahead and simplify this, because what's 36 divided by 3, or 36 over 3? That's 12. So this gives me 3r equals 12. And then the last thing I can do is solve for r by dividing by 3. And that's going to give me r equals 4. Okay, so notice that with proportions, you're freaking out because it looks like a lot of fractions, but really the math is quite easy. And notice how I'm repeating this process of getting rid of the denominator and then just simplifying the numerator. So let's see if we can solve one last problem. I have 7 over 112 equals c minus 3 over 8. I'm going to start with this 8 first. Get rid of it by multiplying the 8 across, put it over 1. See if I can simplify. 8 goes to itself one time, and it goes into 112 14 times. So now what am I left with? Well, 1 times 7, that's going to be 7. 1 times 14, 14 equals c minus 3. Uh-oh, Pescadios. I thought we could avoid it, but we can't. 7 divided by 14, is that 2? No, it's not 2. Simplify this fraction. 7 goes into itself once, into 14 2 times. That's equal to 1/2 equals c minus 3. The last thing I want to do is add 3 to both sides. Oh, Nelly. So I got 3 plus 1/2 equals c. Oh my gosh. Well, what do I do here? Remember, I'm going to take 3 over 1. Okay, and then I have to find, if I'm saying, I'm going to write on the side here, so just pay attention. I'm going to take c equals 3 over 1 plus 1 over 2. Adding fractions, here's review. What do? Got to get a common denominator. So if one of my denominators is 1, I can change it to 2. Second fraction stays the same. 3 over 1 is going to become 6 over 2. Add these together. C is going to equal 7 over 2. Remember, all I do is add the numerators together. So I get c equals 7 over 2, which can't be simplified. So right there, that's my answer. Okay, a lot of work here with solving proportions. They, again, don't get confused that they look like fractions. Solving is actually quite easy. So you're going to have to apply some things from last chapter. I hope you enjoyed, kids. I hope you're ready to go in this chapter. And good luck on the practice in class. Again, if you have any questions on ratios and proportions, bring them to class. And we'll see you there. Peace out, my friends.